Next on the list is the slump test, AASHTO T119. This is by far the oldest and most widely used test to measure the uniformity and consistency of concrete. Variations in slump generally indicate that changes have occurred in the properties or proportions of cement, aggregates, water, or admixtures. The equipment needed for slump tests includes a standard slump cone, a standard tamping rod, a scoop, a base, and a ruler or measuring tape. The slump cone should be reasonably clean, especially inside. The surfaces should be smooth, with no dried concrete on them. Also, there should be no major dents. A standard tamping rod is smooth with a rounded tip. Makeshift rods, such as cut-off reinforcing bar, are unacceptable. The base for the cone must be strong, rigid, and stable enough to support the tester as well as the concrete and equipment. It needs to be level and firmly supported so that it won't rock or bounce. The sample should be brought close to the test location and remixed if necessary until it looks uniform. The test is begun by first dampening the inside of the slump cone to keep the concrete from sticking to it. Then, the base is dampened as well, so that it won't absorb water from the concrete. But no freestanding water should be left on the base. The cone should be set down on the base as close as possible to the sample. Next, the technician steps onto the footholds at the bottom of the cone and stays there. That's why the sample and cone need to be close to each other. The cone is filled by moving the scoop around the top to distribute the concrete as evenly as possible. The filling is done in 3 layers. Each layer should take up approximately 1/3 of the cone's volume. So the first layer should come up about 2.5 inches from the base. The second layer should come up about 6 inches. That's about halfway up the cone. And the third layer should overflow the cone. As each layer is placed in the cone, it's consolidated with a tamping rod. Starting at the perimeter, with its rounded tip downward, the rod is inclined slightly to match the slope of the cone. Otherwise, the concrete closest to the cone's sides will not be properly consolidated. The rodding should go to the bottom of this first layer, but just tap the base. Each layer is rodded 25 times, with about half of the strokes made near the perimeter. A spiraling pattern should be followed as the rod moves toward the center of the cone. The strokes are distributed uniformly. As the rod is moved away from the perimeter, it's returned to the vertical. The second layer fills about half of the cone's height. It's rodded the same as the first, with one difference. The rodding should just penetrate about 1/2 inch into the first layer, not all the way down to the base. The third layer should overflow the cone. That way, the concrete stays above the cone throughout the rodding. If it drops below the top, the rodding should be stopped. More concrete should be added, and then the 25 spiraling strokes should be completed. and the rod should just penetrate the top of the second layer about 1/2 inch. With the cone full and the rodding completed, the surface of the concrete is struck off by moving the tamping rod across it in a screeding and rolling motion. The concrete surface must be level and fairly smooth. Next, any concrete that has spilled around the bottom of the cone must be removed. Otherwise, it may keep the sample from slumping properly when the cone is lifted off. However, the technician must be careful not to move the cone and disturb the concrete. Basically, both sides of the cone must be held still by pressure on either the handholds or footholds until the cone is removed. To remove the cone, both hands are placed on the handholds and downward pressure is applied to keep the cone stable before the feet are removed from the footholds. Now the cone is pulled straight up, slowly and steadily, without twisting or tilting. The removal should be completed in about 5 seconds. Slowly enough that the concrete doesn't pull on the cone. The cone is then set on the base, next to the concrete, without touching the concrete or jarring the base. Immediately, the tamping rod is laid flat across the top of the cone, extending over the concrete. A ruler or measuring tape is used to measure the distance between the bottom of the rod and the top of the concrete. The measurement should be made to a point that is directly above the center of the bottom of the concrete, not at the center of the top. The entire slump test must be accomplished within 2 minutes, as measured between the adding of the first layer and the measuring of the slump.